Hey guys, it's me, Chance. Today we are going to take a basic player character and make its movements feel juicy. Right here is a basic player character that can move around and jump. Now this is the same character with a few tweaks. This includes player acceleration and deceleration, jump buffering, jump variation, and a coyote jump. The acceleration and deceleration is pretty easy to understand. It's just how fast the player gets to top speed and how fast they slow down when you stop pressing the move button. Jump buffering is when the player touches the ground. The game checks if the jump button has been pressed in the last blank amount of seconds. If it has, the player jumps. Jump variation is just as simple. All it checks is when the player jumps. It calculates the jump height based on how long the jump button is pressed. A coyote jump is when the player leaves the ground. It gives the player a blank amount of seconds to still jump even though they left the ground. Now let's implement them into Godot. So right here we have two basic player characters, one named Sig and the other named Chad. Sig is the basic one with nothing special about him, just move left and right and jump. And Chad is the one which has all the acceleration, deceleration, all the special things about him. First, let's look at Sig. So if we go into Sig's script, by the way, these are just exact copies of each other right here. But if we go into Sig's script, he just has pretty simple stuff. Velocity, move speed, gravity, jump force. In physics process, just apply gravity to velocity and get velocity move and slide, velocity vector 2 dot up. In process, if we press jump and is on floor, jump velocity negative jump force, which means it's going to go up because negative for y-axis is up. This is x direction, which is basically meaning if we're pressing right, it's going to equal to 1, left is -1, and nothing is 0. So if we're pressing something, take the velocity, you have it equal to move speed, which is the strength, times the direction, else velocity equals 0. That's pretty simple. Now Chad is much more bigger, I guess you could say. But let's go through this. Has the same basic variables, move speed, gravity, jump force, but I got a couple new ones here too. For instance, min jump, which is basically the lowest jump height you can get by just tapping the keyboard, tapping the spacebar. Move acceleration and move deceleration, these are just weights for how fast you accelerate and decelerate. These can be between 0 and 1. Can jump, which is equal to force. Coyote time and jump buffering, these are just timers for how long you have when you go off the edge to still jump and how long before you land on the ground. If you press jump, it will make you jump. And has press jump equal to false. Physics process exactly the same. Process function is split up. It's split up into 3 separate functions. Check if player's on floor, check player movements, check jump. Let's do check if player's on floor first. If player's on floor, can jump equals to true, else if can jump equals to true means we aren't on the floor anymore, but we can still jump. Wait until the coyote timer's out, then set can jump to false. This just gives us the last fraction of a second to still be able to jump, or however long you have the coyote timer for. Now check player movements, x direction, same thing as before. If we are pressing something, take the velocity of, take the velocity, have it loop between itself, the desired speed you want to go to, which is, in my case, move speed times direction, and the weight, which is move acceleration. Else if we aren't pressing anything, but we aren't on the floor, so we're in the air, just midair, not doing anything, instead of going to our desired speed, which is move speed, have it go to 0, which is slowing down, and move deceleration divided by 2. Next, it's the same thing. If we aren't pressing anything, but we're on the ground this time, just take velocity and go to 0 by move deceleration. Now finally, it's pretty simple, check jump. If we press jump and we haven't pressed jump yet, set has press jump to true, wait until jump buffering's out, then set it back to false. Now, if we have press jump and we can jump and set can jump to false. Pretty much this does is if you're in the air and you press jump, let's say jump buffering's 1 second, and you hit the ground 0.5 seconds later, it still says has press jumped equals the true. So it's going to have you jump. But if you say you land on the ground 1.2 seconds later, it's going to already be false at that point, so you aren't going to jump. That's why it's called jump buffering. It's like, so you don't have to do perfect timing, like frame perfect jumps. It gives you a little bit of leeway. And this is just for the jump variation. Basically, if your velocity is lower than negative min jump, just set it to negative min jump, and that's pretty simple. Also, if you release jump, so not press it, but release it, so when your finger lets go. And that's basically it. Nothing real special about it. It's pretty simple. I'll let you guys look at the code real quick. I'm going to put this on GitHub, so if you guys want to look at this at all, here it goes. So let's just take Chad and see how he plays. You got acceleration, deceleration, variation, jump height, as you can see. Coyote time, because when we pressed jump, we were in the air, but we still jumped. And jump buffering, because we're pressing jump when we're not exactly on the ground. So it still allows us to jump when we hit the ground though. And that's basically it. There's nothing real special about it. It's just quality of life stuff that you might want to add to your platformer. Might make it feel better, who knows? So thank you guys for watching the video. If you like it, press like. If you want to subscribe, you know where that button is. Comment if you want to. I always enjoy looking at your comments, every single one of them. And I shall see you guys next time. See ya.